Hey buddy, welcome to another changelog episode of How AI is Built. We will keep up to date with our preferred data and AI tools and people. Today, we are catching up with Kirk Marple to discuss how he builds integrations into different tools. Learn how you can connect and get data out of anything so you can feed your AI models and vector databases.
I've kind of looked at this kind of data flow model. I've always kind of called it like a two-sided funnel. I mean, you have all of your funnel of data sources into some sort of canonical format in the middle, and then that format can be published out. And I've kind of used that pattern for years where no matter if the data source is coming from cloud storage or we call this feeds, and so it's kind of based on like RSS feeds as a concept where there's individual posts that you can break it into. Essentially, it generates like a stream of data. And so you were just talking about CDC a second ago, but we really try and map all data sources to that. And so if you have an S3 bucket, we'll enumerate all the files, create essentially file posts, almost like as if it were a feed of data. That maps really well to an event-driven architecture. And so we're essentially creating a stream of ingestible objects that typically at that level just have a URL. Like we're just saying, okay, here's go ingest when you receive this object, this like event on the queue, go ingest from here and put it over here. And we call the destination site. And so we're pulling from a source and copying it or downloading it to a destination, and they're done individually. And so one big architectural thing is making it run in parallel really well. So, I mean, if you have 100,000 files on an S3 bucket recursively, you want to be able to kind of feed a ton of data to your destination at once. And so that's why we kind of use this competing consumer model where we just like feed everything into the queue, that gets buffered, and then we have a bunch of serverless functions that can process that data in parallel. So really, I mean, that pattern, it's kind of multi-level. And so there's like an interface that at the code level that we have that's like enumerate files. I mean, it's like file service, and we're a .NET C# house. And so we're using like an interface to a file service that has the capability to look at any data source and enumerate it as a list of entities, a list of items. That actually makes it really easy to build new data sources. So we kind of formalized an interface for accessing these things. And then once we had AWS and Azure build, we could go to GCP, and you just had to implement the interface in a service model. And now you can basically everything upstream works. And so that's been another big pattern for us is as long as we can kind of have these well-defined interfaces of like, okay, you have to, I mean, list files, delete a file, get a file. And once you can kind of do that for one data source, you just implement it for the other data sources, and all the downstream stuff works properly.
And how do you stay up to date? So as new files come into the data sources, how do you manage that?
I mean, the classic is, I mean, there's polling or there's some event-driven kind of webhook interface. I mean, polling works pretty much for everything and with cursoring. So you have to store the last place you were in the data source and then continue from there. And so I think we support polling for everything today. There are a couple cases where you get what's called like a Delta query that like the Microsoft Graph API gives you access to a bunch of different things like SharePoint and OneDrive. And you can basically give it a cursor and say, okay, the next time it polls, give me since the last checkpoint. And that works really nicely. And so, I mean, that not all APIs support something like that, but when they do, we use it. And so we can get deltas. There are other things where you may want to subscribe to what's called like a blob trigger and say, we have this model where we have essentially a watch folder that you sign up to us, you get a piece of cloud storage. So like we'll create a storage container for you, and you can actually just drop files in there and we'll ingest them. And that's more of an event-driven model where we subscribe to those events. When we receive those events, we automatically process them. And so there's a balance of performance of like the polling is good in a way because you're batching, but for some situations, the latency might be a problem where you could set the polling interval at like a minute or 5 minutes, and at least you're batching those. But if someone wants to, like, if they're editing a Google Doc and you want to readjust it immediately, then it may not be you may have too much lag. And so we haven't seen that be a problem to date. I mean, we're looking at other ways where we can add in subscriptions and kind of more event-based stuff. But currently the default is kind of a more of a batch polling model across the board.
Yeah. And how do you actually, if like the GraphQL interface isn't given, how do you actually implement? Like, what was the state before? Until what file did I already scrape? It's like a combination of like IDs, headings, timestamps.
Yeah. So what we do is we separate out the two things. So there's content, which is, think of it like your folder of files. That's like all your files, your web pages, or things like that. And then we have feeds that basically generate content. The feeds are kind of familiar, if you're familiar with like an actor model, where it's like a process that has state. And so we actually use feeds to that level where a feed stores its own state. And so it's actually like a little service that's running in the background as an actor, and it stores a cursor. So it knows where it's pointing to, it knows where it has to read from, it knows the last cursor that it read, and it just wakes up every few minutes, depending on the periodic nature. That's how we manage it. So and that was something where I really like the actor pattern, because you can really dedicate the control to that feed. And we use the actor model in a couple other areas as well.
Can you maybe elaborate a little bit on the actor model?
Yeah.
What that means?
I mean, essentially, it's like having a lightweight service, almost like a daemon process that is just kind of running in the background. And we use what's called durable functions and durable entities in .NET. And so that is actually something where it manages the scalability of the callbacks and all the data points of when the code gets run, but it also manages the persistence of that. And so the feed entity itself is serializable. And so after you do a polling pass on that, it saves itself back to its save state. And so the next time it wakes back up and processes, it has the current state. So like, you don't need a separate database necessarily for that. Like, it manages that. They're very scalable. I mean, you could have thousands of these running in parallel.
Yeah. And how do you actually think about changes to documents versus entirely new files?
Yeah. So in-place ingestion is something that we handle. So we do a couple different things. So we store the E tag for like web pages, and some other sources give us an E tag back. So that essentially is like this hash that you can know if something's changed. We support a last updated date, like a last modified date. And so if we go back and reread, like Notion's a good example. I mean, you'll get a change. You'll recognize that, hey, this page has changed. We'll ingest in place. And so a lot of that is really important, where every piece of content has an ID. And so we use a GUID that's a unique identifier. And that piece of content may have metadata, it may know when it was created. But if we recognize that the source changed, we don't want to change that ID, because somebody might be using that, or it's on, in the UI or linked somewhere else. But we just want to refresh the guts of the content. And so that's really important, supporting that in-place ingestion. And we support it from like web pages. Like, if we realize that, hey, it's a web page, we've already ingested it, the E tags change though, will kind of refresh itself internally. Basically, what that means is rerunning the content workflow, which means like, okay, re-extracting the text, re-embedding, like deleting existing text vector embeddings, re-embedding it, putting it back into the search index again. So it's kind of like we create it, like we rip the guts out of it and then fill it back in when we re-embed it.
Yeah. And at what point in the pipeline do you actually start to normalize the data to bring it into your own data format?
So we call that preparation. And so ingestion is kind of identifying, where does this live originally? Like, is it a web? Is it on a web server? Is it in cloud storage or whatever? We have the ability to, essentially that's the caching of it. Like, we'll download it from somewhere, because we have to be able to read it. And so it's like, and we don't continually read data from the source. We cache a version of it. And then, so we're always reading it from local blob storage. It's local to us and local to the customer. And that's really important for us, because we can at least guarantee the performance. And as it's going through the stages of the workflow, you're not going to deal with like network disconnects or the file getting deleted, or, it makes sure that you have a cache of that. And so after we get a version of it, we start preparing it. And that's where we do like text extraction. We create like a JSON canonical version of that has all the pages broken out, all the chunks broken out. All of that is just done automatically during the preparation phase. And that's kind of that fan in I was talking about of no matter if you got a Notion document, you got a Slack message, if you got a PDF on an S3 bucket, they end up looking the same internally. And that's super important for us to have that canonical format, because then as we process that and go downstream from there, all that's really consistent.
And what's your tech stack going through the flow? Like, would you highlight anything?
I mean, we're running on Azure, so we're using Azure Functions for our serverless frameworks. The database is Cosmos DB. We use that in a couple different ways for our JSON kind of document store and our graph store. And then we're using what's now called Azure AI Search for like classic full text search, but also vector search now. And so I looked at, there's other great vendors. Like the Podcones and the Qdrents and everybody. We had already been using Azure AI Search for just full text search. And then they offered vector search, I guess maybe last year this came out. And it was really easy to integrate for us. So we just ended up staying with one vendor for our whole search architecture.
And over time, do you think the architecture will progress more towards like a Lambda or a Kappa? So Lambda combining like the batch plus the real time, or the Kappa where everything basically is processed in real time directly?
I think we're more Kappa in that idea today. Like everything is basically a stream. Everything gets put on Event Hub, which is kind of similar to Kafka, and we're processing everything as an event. Now, one of the things that's come up lately is some sort of more batch processing, where like with OpenAI releasing cheaper batch embeddings or batch prompting, that may be something that we look at. And so that maybe we do part of the workflow in real time and then maybe batch up and group things together and then do some batch processing and then kind of finish the execution later. So I think it is we're more like Kappa today, but I think more for cost optimization, we may do some more batching in the future.
Is there anything else you would highlight, any mental model, how to think about data sourcing, data ingestion?
Having consistency is really important. And so I think having the ability to plug in new formats, it's like when we just added issues as a new data type. So Jira tickets, GitHub issues, linear, the reusability of your pattern becomes really important. And so we basically built an issue service. So there's something you can enumerate all your issues in your data source and it just kind of a standard access method. But once we got the post in the feed, it was probably marked down. It had metadata, and we could just plug that right into the rest of our data flow and literally had all these built in like a couple days. And I think that's really the biggest takeaway for me is having the proper patterns. You can now build data sources faster and just plug into your existing architecture. And that's a lot of what we optimize for is, as we want to add new formats or new data sources, it's usually a really quick, on the order of days, not weeks kind of operation, because so many layers of it are already built. We basically just have to crack it open and get marked down and get some JSON metadata. And then the rest of it just works. And the big thing for us is I've seen other architectures in the RAG where they try and differentiate, I'm doing RAG over documents. I'm doing RAG over audio. I'm doing RAG over whatever. And to us, it's abstracted away. It's just RAG over content. And that's why it makes it really easy for us to plug in things upstream and nothing changes downstream, where you could just, as long as we can crack it open, we can talk to it.
Are you, or how much AI are you already using in the initial phase of the data ingestion?
At the ingestion phase, nothing. The preparation phase, the embeddings, and we're using maybe things like OCR models or semantic chunking to kind of get that canonical data. We also can do things like summarization. So you can auto summarize data upon ingest. I would say it's all optional. If you look at the defaults, we're not using it other than the embedding models, but you can do a lot of extra stuff like entity extraction and summarization and things like that on top of it.